Hi, my name is Dominic Wong, and today I'll be your presenter for Team Trees for the production of 1,3-butadiene from N-butane. So before we actually dive in about our production, let me just show you guys a quick example about what we actually do.
Motorsport, put that thing in sports, shout it bad, pop it like a court.
As you can see here, cars need tires, and sport cars uses more tires. So we're not gonna make tires, so we're gonna up our game and we're gonna sell the thing that make tires. Hence, butadiene. 1,3-butadiene to be exact. So butadiene is an organic compound and it's a colorless gas and not soluble in water. Well, in normal temperature that is. But it also has other uses aside from making tires. For example, rubber manufacturing and as well as plastic production. So it has actually a wide range of use, not just only tires. So next up is analysis. Why we use N-butane compared to other raw materials? There is ethanol and there's also propylene. So we did a comparison and did a little study and we found that N-butane is the most optimal for our condition. Even though ethanol and propylene, they do have the high purity rate and maybe perhaps higher than N-butane for ethanol, but the turnover rate, or we could say as the economic potential for N-butane, is the highest, and as well as the operating conditions is not that expensive. So therefore, N-butane is our best choice. Now we got our best choice, let's just take a look at our strengths, weakness, opportunities and threats. So we know our opportunities. Cars won't run without tires, and we know our strengths. We have a high economic potential for N-butane. So let's just take a look at our weakness. Well, our weaknesses, there's actually just major one. There's one very major weakness in our plant that everybody should know, is that we cannot operate the plant by ourselves. Let's just say, for example, we cannot buy N-butane in liquid form because that's how we buy N-butane. And if we buy it, the cost will skyrocket and we won't earn money. So our only way is to depend on the plant that produces N-butane and supply it to our plant. So if there is no one that can able to supply us N-butane in gaseous form and in huge quantities, boom, that's it, the plant just burn, crash, poof, all your money just poof. But if there is people, whoa, yeah, you're gonna earn billions and millions. Okay, now let's talk about process flow. So it's gonna be a little bit complicated, so just bear with me for a while, okay? So I'm gonna explain it as simple as I can. So we have N-butane. So this N-butane is gonna go to a reactor called a non-oxidative dehydrogenation reactor, which is gonna convert from butane to butene. Now this butene gotta convert to butadiene, which uses a reactor called oxidative dehydrogenation reactor. So now we have butadiene and we have a lot of other stuff, butanes and butenes as well. So we're gonna separate them using 3 distillation columns. So the first distillation column is gonna separate out some air because we use air to convert from butene to butadiene. And then the second distillation column is gonna eliminate most of the butenes, and the third distillation column is gonna eliminate more butene, and voila, you get your butadiene, 1,3-butadiene, 99.7 purity. Easy. And if you guys want to know more about it, there's always Q&A. Now we're done, let's move on to HSSE. So as we know, our materials are they're quite dangerous. So N-butane, for example, they have hazards. I mean, it causes frostbites, and it may cause burns, and it explodes when it mixes with air. It's actually a very flammable explosive. And butene is kind of same. It is flammable, and it also will cause explosion under severe heat. So both of our reactors, yeah, it can explode anytime if we didn't build it properly. And butadiene, same thing. If it doesn't explode, but if you get in contact to it by too much, you die. So technically, N-butane, butene, and butadiene, they kind of kill us if we don't handle them properly. So in order to prevent this from happening, we do actually have preventions from it. So basically, in layman term, we actually hire the right people, make sure we set it up, no leakages, nothing, because we're dealing with extreme explosive and we're dealing in mass amounts of butanes and butadienes. So definitely we're going to take extra precautions in making this particular plant. So it's definitely a no joke matter. The HSSE to me is the most important part of this whole slide, because if there's anything wrong with the plant, that's it, boom. You lose money, I lose money, I die, that's it. It's a lose-lose situation. There's no happy ending. So moving on, we're going to talk about our planning. So definitely, one of the places we considered is Kawasan Perindustrian Gebang Pahang, which is near our material supplier and product customer. Hence, which reduces most of our transportation costs. But we also have a projection planning with 2 stop loss, which leading up to 16 years, which could lead up to 526,000 tons per annum, and will generate us around $160 to $240 million gross profit, with a capital around 50 to 100 million. So these are all estimates because we haven't actually took into account with most of our utilities yet. So this is only just a number that for you to actually estimate how big this thing can actually lead up to. So thank you very much for enjoying the video, and I hope you guys enjoy it. So if you guys have any questions, you guys can ask in the Q&A, because most of the stuff we can actually explain in full detail, or else it will drown out some of the certain parts. Thank you very much for watching again, and let's start with the Q&A.